Hello and welcome. You should be on page 19 of your quarter one Algebra 1 notebook. This video will cover solving linear inequalities. The great news about solving linear inequalities is it is incredibly similar to solving linear equations. Like solving linear equations, we focus on some elements or properties. In this case here, we're calling them axioms, which are statements that are proved to be true. We've got addition and subtraction properties of inequality. And like a property of equality, if I add or subtract the same number from both sides of an inequality, I'm going to have an equivalent inequality. Where it is different in solving inequalities is with multiplication and division, because it depends on whether or not I'm multiplying by a positive or negative number. If I multiply or divide by a positive number, the result will be an equivalent inequality. However, if I multiply by a negative number, in order to have an equivalent inequality, I have to flip the sign to produce an equivalent inequality. So if you're multiplying by a negative number or dividing by a negative number, you flip the sign. And this should be familiar from either foundations or from pre-algebra. So let's take a look at some examples. Here we have number one, and let's read the directions, of course, first. Solving inequalities is very similar to solving equations with one notable difference. So that doesn't really actually give me many directions. We're just going to solve them. So if I look here at number one, I'm going to still think to myself, it's just like solving an equation. Do I have to distribute? No, there are no distributing. Do I have like terms to combine on this side? No. Like terms on this side? Again, no. Are my variables on the same side? Well, I have x's over here and x's over there, so it looks like I would like to combine my variables. I'm going to move 4x from the right to the left. Now, I am not multiplying or dividing, so I'm just subtracting and adding, which means this does not impact the sign. 6x minus 4x is 2x minus 2 is greater than, that cancels out, and I now have 8. So here is a two-step inequality. I'm always going to remove the constant with my variable first, so I will add 2 to both sides. I have 2x is greater than 8 plus 2, which is 10. And here's the step where I may have to flip the sign. Well, in order to isolate x, this is multiplication, so I'm going to divide both sides by a positive 2. Because I'm dividing by a positive number, I do not have to flip the sign. So in this case, x is greater than 10 divided by 2, which is 5. In our next example, I have a one step. There's no distributing, no combining of like terms. The variable is on one side. And what I see is I have x divided by 5. So this represents division. I'm going to use my inverse operation, which is multiplication. I'm going to multiply both sides by 5. Now this is a positive 5, so again, I will not flip the number. I realize that this is a negative 12 on the other side, but that is not what is important. It's whether or not you're multiplying both sides by the negative number. And in this case, I'm multiplying both sides by a positive 5. This will cancel, and I have x is less than or equal to negative 12 times 5, which is negative 60. Oops. Let's take a look at number 3. I have negative 4 minus x is greater than or equal to negative 6. No distributing, no like terms on either side to combine. My variable is over here by itself. I'm going to remove my constant first with subtraction or addition. I'm going to add 4 to both sides. Negative 4 plus 4 is 0. I bring down a negative, and I'm going to put a negative 1x. And that will be greater than or equal to negative 6 plus 4, which is negative 2. I added the -1 because x is only alone if it's literally alone. A negative x is not alone. So I need to divide both sides by a -1 in order to really isolate this x. And ding, 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 I am dividing both sides by a negative number. So this is a situation where I would flip the sign. I'm going to flip the sign. X is less than or equal to -2 divided by -1, which is a positive 2. So x is less than or equal to positive 2. The last question on this page asks for this two-step equation. There's no distributing, no combining of like terms, variable on the same side. But I do have a constant. So this is at +5. I'm going to subtract 5 from both sides. X divided by -3 is greater than -5, -8 minus 5, which is -13. And in this case, again, I have division, so I'm going to multiply both sides by a -3. Again, it's divide or multiply both sides by a negative number. In this case, it's dividing by a negative sign, so I will be flipping the sign, and x is less than -13 divided by -3, which is a positive 39. Alrighty. In number 5, another element that you should be able to do is to graph your solution to a linear inequality. Unlike a linear equation where you have one distinct answer, inequalities suggest that there are many more answers. Any answer that is less than or equal to -60 works for this equation. So -61, -62, -63, and so on. Any number greater than 5. So 6, 7, 8, 9, 10, and so on. 5 does not work in this case because I don't have the or equal to. And of course, -60 does work in this case because the -6, that or equal to is there. I'm going to graph number 4, so I need a 39. I know really that this is not a huge number line, so I'm going to place 39 here in the middle. I know that 40, 41 are after, and 38, 37 are before. If you remember from foundations or from pre-algebra, for my less than or greater than signs, I use an open circle. So I will put an open circle here at 39. And for my less than or equal to or greater than or equal to, you use a closed circle. What I really like about graphing inequalities is if my variable is first, this inequality is pointing the direction in which my line will go. So it is pointing this way, less than 39. And that is it for page 19. Thank you so much and see you later.